After the addition, the resultant is equivalent to the decimal value of a binary number. So any number with power 0 is always equal to 1. Here 1 into 1. Why? Because 2 power 0 is 1. 1 into 1. So wherever we are having this binary point which is coming right side to that binary point, you have to give a negative weightage until the decimal number which cannot be divided further, or when the quotient becomes 0, at the time we have to stop. Hello everybody, a warm welcome to one and all. Welcome back to the session 6 of Unit 1 in the B.Ca's first semester subject called Fundamentals of Computers. I am Rohini TS, Department of Computer Science, Vidhyaashram, First Grade College, the Temple of Excellence, MYSURU. So we'll see the recap of our previous session. As we discussed in the last session of this unit, we had a discussion regarding the number system conversion. In that we got to know how we are going to convert this decimal to binary, and also we got to know regarding how this decimal fraction will going to be converted into binary. So in our today's session, we're going to learn about the binary to decimal. So you need to understand one thing. Any number system to decimal then should multiply. Decimal to any other number system, then we have to divide in the number of the to be converted into number system. For example, decimal to binary, divide the decimal number by 2. Decimal to octal, divide the given decimal number by 8. Decimal to hexadecimal, divide the given decimal number by 16. So, if any other number system into decimal, binary to decimal, multiply it by 2, octal to decimal, multiply it by 8. Then hexadecimal to decimal, multiply it by 16. Okay, that is what you have to remember. Any other number system to decimal, decimal to any other number system. Those two possibilities you have to understand. So in our today's session, we're going to learn how we are going to convert from binary to decimal. You can see here, binary to decimal. So it needs to be multiplied. Then decimal to octal. Then it is of dividing the decimal number by 8. Then octal to decimal, multiplying the given number by 8. Okay, we'll see each one of the type one by one right now. We'll see the first one, that is what conversion from binary to decimal. What is the first step? First we have to start with the rightmost bit. So I have a certain binary digits here, that can be zeros or ones. So we have to start with the rightmost digit. After that, take that bit and multiply it by 2 power n. We have to find out its positional value. So we got to know regarding its weight already. 2 power 0, 2 power 1, 2 power 2, that and all we know. So which is coming to the right of a binary digit. For example, 110 point, that is binary point 01. So all these number we should give a positive weightage. So the number which is right side to the binary point, we have to give a negative weightage here. That is what. Then when n is the current position which is beginning at the 0. So this will start with the power 0 and increasing by 1. Next it will be 1, 2, 3 up to n number or last number. Then it represents a power of 2. So it will going to be power of 2, like 2 power 0, 2 power 1, 2 power 2. In this manner we are going to have it. Then what we have to do in the step 3? Then we have to add all the products. So by multiplying it, what and all we are getting, that needs to be added together as a product here. After the addition, the resultant is equivalent to the decimal value of a binary number. So what we are getting after the addition of all the sum as a product, then we can expect that number is to be what? Decimal value which is equivalent to the binary number, which is we are acting as a input here. Okay, we'll see the first example here. Convert the binary number 10101111 base 2 to decimal. So I need to start with the rightmost bit, that is what 1. We have to start writing from here. Write down 1 into 2 plus 0 into 2, then 1 into 2 plus 0 into 2 plus 1 into 2 plus 1 into 2 plus 1 into 2. Okay, I need to start giving a weightage from the rightmost bit. So here I don't have any fractional part, I don't have any binary point. So I will start giving a weightage from 0. So 2 power 0, 2 power 1, 2, 3, 4, 5 and 6. Fine. After this, what we have to do in a second step? So 1 into 2 power 6. So most of you will going to write like this. So you are going to consider this as 12, but this is the wrong thing. 2 power 6 in the sense what? 2 into 2 into 2 into 2 into 2 into 2. 2 2s are 4, 4 2s are 8, 8 2s are 16, 16 2s are 32, 32 into 2 is the 64. Okay, so that 1 into 64 plus 0 into 2 power 5 up to here. What is that? 32, right? Plus 1 into 2 power 4 up to here, that is 16. 1 into 16 plus 0 into 2 power 8. 2 2s are 4, 4 2s are 8. 0 into 8 plus 1 into 2 power 2, that is 2 into 2. It will be 4 plus 1 into 2 power 1, that is 2. Any number with power 0 is always equal to 1. You need to remember it properly. So, any number with power 0 is always equal to 1. Here 1 into 1. Why? Because 2 power 0 is 1. 1 into 1. Now you can see 1 into 64 is 64 and 0 into 32 is 0. So no need to consider that for addition. So though you wanted to take, you can take 64 plus 0. After that 1 into 16 is what? 16. Then 0 into 8. Again it will be 0, no need to consider, plus 4 into 1 is 4, then 2 into 1 is 2, 1 ones are 1. Now, if I add all these things, so 16 plus 4, 20, 22, then 23, 23 plus 64, 23 plus 64, it will be 87. This is what the equivalent decimal number for a given binary number. So, here therefore, 10101111 of base 2 is equal to 87 base 10. Fine. This is how we are going to convert from binary to decimal. My input was this one, binary number. Now, I got the equivalent 87, which is of base 10. That is of what? Decimal number. We'll see one more example here. Let me consider 10110. Then, let me go with this fractional part. Consider 1 and 0. This is my what? Binary number. I want it to be converted into decimal number. Already I showed you regarding the 8421 format, isn't it? 8421. So here we have 5 letters or 5 bits we have. So what if I multiply it by 2? Then it will become 16. Let me write 1 0 1 1 then 0. So now wherever we have 1, that number I should add 16 plus 4, 20, 20 plus 2, 22. So, let me see, this is my answer. Am I going to get the 22 for this whole part or integral part? We'll see at the end. Now, let me start with writing 1 into 2 plus 0 into 2 plus 1 into 2 plus 1 into 2 plus 0 into 2. This is what? Up to my integral part. Next, what we have? 1 and 0. How I am supposed to write for that? Same thing. 1 into 2 plus 0 into 2. So, till here, this is what? Integral part. So, I need to give a weightage from here. 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4. Fine. Then, after that binary point what we have, that is considered as what? Fractional part. For that we have to give a negative weightage. So, it will be 2 power minus 1, 2 power minus 2. Next, what is the second step now? 1 into 2 power 4. 2 2s are 2 into 2 into 2 into 2. 2 2s are 4, 4 2s are 8, 8 2s are 16 plus 0 into 2 power 3 is 8 plus 1 into 2 power 2 is 4 plus 1 into 2 power 1 is 2 plus 0 into 2 power 0 is 1 plus. Here you need to be cautious. How we are supposed to write? Write it 1 into. Then what it will be in the inverse form? 1 by 2. Okay, plus 0 into 1 by 2 power 2 is what? 4. In this manner you have to write. While doing a calculation also you have to follow the same format. Write 1 into, make it as inverse, 1 divided by 2. 2 power 1 is 2 itself, that is why 1 divided by 2 is we have to write plus 0 into 1 by 4. Why? Because 2 power 2 is 4. Let me erase this. So, 0 into 1 by 4. So, now 1 into 16 is how much? 16 plus 0 into 8 is 0. No need to write. 4 ones are 4 plus 2 ones are 2. 16 plus 4, 20. 20 plus 2, 22. Did I got it? Yes. This is how can you confirm your answer. After that what we have? Plus, then 0 into 1. If I multiply again it will be 0. No need to worry. Then 1 into 1 by 2. So for this, no need to write 0, then it will be 1 into 1 by 2. It will be 0.5 plus, if I multiply anything, again it will be 0. Fine. Then it will become 22.5. So now what it will become? 22.5. So this is what integral part, this is fractional part. And what is the base or radix for this? We are converting it to decimal, so it will be 10. Okay, this is how we are supposed to do. So wherever we are having this binary point which is coming right side to that binary point, you have to give a negative weightage. I hope you all understood regarding this conversion from binary to decimal. Next we'll go with decimal to octal. Decimal to octal in the sense what? 0 to 9 will be the input. For output it will be 0 to 7. Why? Because we are dealing with octal. Then what are the steps we have to follow in order to convert from decimal to octal number? First step is what? Divide the given decimal number by 8. As I told earlier, if the first word is decimal and then any other number system, then divide this decimal number system by the to be converted type of number system. Now we are converting decimal to octal, so we have to divide the given decimal number by 8. Then take the remainder and record it on the right side, which we did for the decimal to binary. In the same way we have to do, and we have to repeat the step 1 and step 2 until the decimal number which cannot be divided further, or when the quotient become 0, at the time we have to stop. Then the first remainder will be considered as what? LSB here, that is least significant bit, and the last remainder is considered as MSB or most significant bit. Then we have to write from MSB to LSB. It will be in this manner. We'll convert. Here I have a question. The decimal number 3034 of base 10 that needs to be converted into octal number. Then how we are going to do that? Before that, we'll write the table 8. This is what the table 8, this for your convenience I am writing here. Okay, what is my question here? 3034. This is what decimal number, it should be converted into octal. So we have to start dividing it by 8. So here you can see that if I go with 8 4s, then it will become 32. I need to go with the previous number. So 8 3s 24, 30 minus 24 will be 6 here. So now it becomes 63. I can't go with 64. So now I have to go with 8 7s, that is 56. 8 7s 56. So now 63 minus 56. How much? The remainder will be 7. Now it becomes 74. So here I can go with 9. That is what? 8 9s 72. 74 minus 72 will be 2. The remainder is 2 here. Okay. So now I got 379 and the remainder is 2. So now here you can expect the remainder which is from 0 to 7. Why? Because we are converting it to octal. So if it is binary, only we can expect 1 and 0 as a remainder. But here we are converting to octal. So it will be between 0 and 7. Next, here again I need to start dividing. So here I can't go with 40. I should take the fourth value, that is 8 4s 32, then 37 minus 32. So the remainder is 5. So now it become 59. So again here I need to go with 7. So 8 7s 56. It will be 59 minus 56 will be, the remainder will be 3 here. We have a 47. Again I need to divide it by 8. So for this I need to go with 8 5s 40. The remainder will be how much? 7. 47 minus 40 will be, the remainder is 7. We can't divide 5 by 8. So I will take 8 zeros are 0 and the remainder is 5. This will be my MSB or most significant bit. This will be my LSB or least significant bit. I have to write from this way. So it will become 5732. So here you can see that the equivalent is how much? 5732, which is of the base 8. The question was what? 3034, which is base 10, will be converted into 5732, which is of base 8. Hence, this is what the result. Okay, fine. So now we are going to divide it by 8. Let me take one more example here. So here I have a decimal number 952, which needs to be converted into octal number. We have to start divide this 952 by 8. So before that, let me write the table 8. Okay, fine. Next. So here I will take 8 ones are 8. The remainder will going to be 1. Then I have to go with again 8 ones are 8. 15 minus 8. The remainder will be 7. So it will become 72. I will take directly 8 nines are 72. We don't have any remainder. So if you multiply 119 into 8, then you are going to get 952. So I have to start with dividing it by 8. Then I will take the digit 2. 8 ones are 8. The remainder will be 3. 11 minus 8 is 3. So it will become 36. So I have to go with the number 4. 8 4s are 32. So 39 minus 32. The remainder will going to be 7. Now I will start with dividing it by 8 again. I can't go with the 8 2s are 16 because 14 is lesser than 16. I have to go with 8 1s are 8. Then 14 minus 8 will be 6. I can't divide this 1 by 8. So it will be 8 zeros are 0. The remainder will going to be 1. This is my MSB. This is my LSB. The answer is what? 1670. Hence 952, which is of base 10, will be equivalent to 1670 of base 8. Okay, this is how we can convert any given decimal number to octal. We'll move to the next concept here. That's all regarding what? Conversion from octal to decimal. So first we have a octal number, then we are converting that into decimal. So when we have a decimal as a second word, we have to multiply. We'll see the steps here. Start at the rightmost bit. How we are done for the binary to decimal, same thing. But here slight difference is what? Instead of multiplying it by 2, we have to multiply it by 8. That is what. So need to remember all the steps. Then go with a example. Take the bit and multiply it by 8 power n. If it is 8 power 0, 8 power 1, anything it can be. When n is the current position beginning at the 0. So if n is 0, then it will be equal to 1. That is 8 power 0 is always equal to 1. Then increment it by next number n power 1, n power 2. That means 8 power 0, 8 power 1. In that way we have to write. Then that will going to represent the power of 8. Then we have to add all the products. So here also you can get to know that when we are adding all those things, that will be equivalent to the decimal number of a octal. Okay, we'll see the first question here. I have a question 5732, which is of base 8, that needs to be converted into decimal number. So when we are converting into decimal number, should multiply the given decimal number by 8. So here I will go with this one. 5 into 8 plus 7 into 8 plus 3 into 8 plus 2 into 8. Now I have to give a power for it. 8 power 0, 8 power 1, 8 power 2, 8 power 3. So then 5 into 8 into 8 into 8. 8 8s are 64. 64 into 8 will be 512. Then plus 7 into 8 square. 8 into 8. 64 plus 3 into 8 power 1. That is 8 itself. 3 into 8 plus 2 into 8 power 0. Any number with power 0 is always equal to 1. So it will be 2 into 1. Then 512 into 5 will be 2560 plus 64 into 7 will be 448 plus 8 3s are 24, 2 1s are 2. If I add all these things, I am going to get 3034. 3034 is equivalent to what? Decimal number. So that what we got as a result here, 5732 which is of base 8. It was octal number. After the conversion, now we are getting a decimal number, that is 3034 which is of base 10. And you can also cross verify it. So you can divide this 3034 by 8. Then if you are getting this number as a resultant, then this will be the right answer that you got after doing a conversion. So in this methodology also you can get it clarified. We'll see one more example here. Let me consider the number as 1375 which is of base 8 should be converted into decimal. Even in your examination also you are going to get the question like this. Any number with its base is equal to question mark and the base. So that means what? Indirectly it says that we should convert the given this octal number to decimal number. Okay, if they are not writing it mention, or if they are not mentioning it as converted into octal to decimal, by looking into this base or radix you must be able to understand. Let me start with a solution here. Write equal, then 1 into 8 plus 3 into 8 plus 7 into 8 plus 5 into 8. Let me give the weightage. 8 power 0, 8 power 1, 8 power 2, 8 power 3. It will be 1 into 8 8s are 64. 64 into 8 will be 512 plus 3 into 8 8s are 64 plus 7 into 8 power 1 is 8 plus 5 into 8 power 0 is 1. So now 512 plus 64 into 3 will be 192 plus 56 plus 5. By adding all these together, we are going to get 765 which is of base 10. Okay. This is how we can convert the given octal number into decimal number system. I hope you all understood regarding the conversion, how we are going to do from the binary to decimal, octal to decimal, decimal to octal. So it's all our today's session. In my coming session, we're going to see how we are converting from decimal to hexadecimal. Now you only can predict. Fine. Decimal to hexadecimal in the sense what? Dividing a given decimal number by 16. Then in vice versa, hexadecimal to decimal, then multiplied by 16. Binary to octal, octal to binary, then binary to hexadecimal. This is what the conversion we're going to do in the next session. Let me meet you there. Until that, keep learning, keep on growing. Thank you.